The fundamental construct behind the idea of Spark is something called an RDD, which stands for Resilient Distributed Data Set. And while the use of RDDs has declined with the rise of Spark SQL and kind of data sets and data frames are kind of used more commonly in Spark 2, it's still good to start off with the RDDs to get a feel for what's going on, and they are still in many ways what's underneath the hood. So, in the last video, we said that we could call text file. In fact, we did this inside of the Spark shell, but we didn't do it inside of an actual program, and we called text file on there. Now, what I'd like to do in this video is, instead of doing this inside of the REPL, inside of the Spark shell, I would like to actually write an application. I should also note here, if you have not yet added into your build SBT this line that brings in Spark Core, you will need it in order to compile the things that we are about to do. These other lines are still for later topics. Okay, so I'm going to go ahead and close that. Here is some code that we wrote previously that plotted these temperatures in this file. I'd like to do this same type of thing, but with Spark. And I'm going to create another little package here. I'm going to call it Spark RDD, because this is where I'm going to put code that uses RDDs for playing with the data. And inside of here, I will make a new object. Let's call this RDD temp data, because we're going to work with our temperature data much as we've done before. And in fact, I'll probably reuse this same case class here because it's handy. And in this case though, because I'm writing a Spark application, I'm going to go ahead and create a main. Like all other mains in Scala. And I need to set up that Spark context. So while the Spark shell gave us that variable SC kind of for free, when we're writing an application, we have to do that ourselves. And in order to make that, first we need to set up a configuration. Now there are many options that we can put into our configuration here, but it is of type Spark conf. And if I do an import, I need to give my application a name. So here's a set app name, and let's just call this temp data. Now, in general, I could stop here, especially if I'm going to use Spark submit to send this to a cluster. Because I want to run this here locally on Eclipse just to show you that it works, I'm also going to set the master. So set master, and I will give it that same string that we put on the command line of local star, telling it that it is going to run on the local machine in a local cluster that uses all available computing resources. Now with that configuration set up, I can make a variable. I'm going to follow the same naming scheme that the Spark shell did and call this SC, and it is a new Spark context of that configuration. There we go. We are set up to run Spark programs now. So, as I did before, I'm going to go ahead and I'm going to read in this file. I don't use a source for it though. Instead, as we saw, I'm going to, how about we call this thing lines. Lines is going to be sc.text file, and our path is that, and I'm going to go with the default partition setting. We haven't really talked about partitions yet, so we're going to kind of ignore that for now. And to make sure that this is working, let's do exactly what I did before. I am going to do lines dot take 5 for each print line to print the first 5. You'll note this prints out a whole bunch of stuff. It's printing out red here. That is because Eclipse prints anything that goes to the standard error in red as opposed to standard out, which will print in black. So our output, the things that are print line here, you'll see wind up being printed in black. There they are. Those are the first 5 lines of that file. Okay, that all looks good, and it's shut down. Everything seems happy. Now, we need to talk a little bit more about what this lines is. So it's an RDD of string. Why didn't I just print it out? Or just do lines for each print line, something like that. Well, it turns out that that would have if this were a really large data set, that could have been potentially bad if it had worked the right way. But the other thing is that lines as an RDD follows somewhat different rules than Scala collections. So it's worth looking at this. So text file returned an RDD. We'll click on it and go see what RDDs do. So you'll notice some methods that should look familiar. Things like filter, a first to give us the first element, a for each. Down here will be a map. Oh wait, I should have passed flat map in there. Yep, there's a flat map. There's a fold. Okay. Up here was an aggregate, as we talked about with parallel collections in Scala. So a lot of these methods are very similar to the things that we have seen previously on Scala. We can do a lot of the same stuff that we did with the collection methods in Scala, and they work nicely on RDDs. But there's a huge difference between the two. So let's take, for example, map. This is a good one because I can probably steal some code and not spend so much time. So we had this code previously, looked something like this, and I'm going to do this and I'm going to modify it. We still have this same lines here. I'm going to get rid of the to array. The temp data, I'll go ahead and import, what do we call that? Standard Scala.temp data. And then we did. So we could do temp data dot here. And temp data dot there. And this code compiles. Okay. So what's going on here? So this has lines, which is our RDD of string, and we get back an RDD of temp data. That's perfectly in line with what we've seen before. The interesting thing to note, though, is that if I were to run this right now, turns out nothing would happen. And the reason is that RDDs have 2 separate types of methods on them. The ones that give back other RDEs, like map and filter and flat map, and once again you can run through the API. If we are looking at something like a map that returns an RDD, turns out that is something called a transform. And the transforms are lazy, whereas all the operations on the Scala collections were eager. As soon as you called them, they did their work. The Spark transforms are all lazy, so simply calling them does nothing. This just schedules some code to be run out across the cluster. It doesn't actually happen until there is an action. So the RDD methods that don't return other RDDs, things like take. If we go look at the API, you will see that take does not return another RDD, it returns an array. There is also a method called collect, which will return all of the values that are in there. Take care with that. Once again, if the data set is too big, you might not be able to bring it all back to the master. There's a count method, which tells you how many things there are. So the things that return anything that's not an RDD, these are actions, and they will force some level of computation to actually occur. So for example, if I do that, or if I do, and let's not do lines, let's go ahead and do data. If I do print line data dot count, we'll go ahead and run this to make sure that our code is happy. Since we copied the main functional parts from another piece of working code, odds are good that this will work. Though, number format exception, no, it didn't. And that was because there was one thing that we did over here that I didn't do in the copy. When I made my lines, I dropped one line. How are we going to do that? Turns out RDDs don't have a drop method in them. It goes from count by approx or by value approx to dependencies. And yeah, there's no drop under the Ds. So how are we going to do this? We need to make the equivalent of a drop. Well, turns out we could do that by a filter instead. So that particular file, let's look in it, less of this file. We want to get rid of this line. Well, it happens to be the only line that contains the word day. Everything else is numbers. So we could do that same operation here in Spark with a filter. And so I'm going to right here, actually I could put it right there, much like I did previously. Dot filter, I want to keep things that don't contain the string day. Let's try running that. You can see there's a lot of work going on here because every time we run this, right now it's starting up a local Spark server. So this says that there were 41,000 entries. I believe we've seen that number before in previous videos. And here are the first 5 data values that were in there. Okay, so we've written a simple application. We've talked a little bit about what the RDDs are doing. We want to continue to explore this and probably do some of the same types of analysis that we did previously using Scala collections, see how we can do them with the Spark RDDs, because clearly there are some differences. We already saw the lack of drop. There is the fact that transforms and actions have fundamentally different semantics in how they work. So we want to see how we can use use the RDDs to do the same types of things that we've done with the Scala collections previously.